Imagine a world without numbers. Silence, no way to track time, no way to measure distance, no way to quantify the world around us. Numbers are the fundamental language of the universe, a language that humans have been deciphering for millennia. From the earliest cave paintings to the latest technological advancements, numbers have been our constant companions, shaping our understanding of the world and our place within it. This journey of numerical discovery begins with the first humans who, faced with the challenges of survival, embarked on a quest to understand and quantify their world. It is a journey that continues to this day as we push the boundaries of knowledge and explore the infinite possibilities of numbers. This is the story of numbers. This is the story of us. Long before the invention of written language, humans possessed a rudimentary understanding of numbers. Driven by the need to track prey, count possessions, and mark the passage of time, early humans turned to the natural world for their first counting tools.
The Ishango bone, discovered in the Democratic Republic of Congo, stands as a testament to this early numerical awareness. Dating back over 20,000 years, the bone features a series of carefully etched notches, arranged in distinct groups. While the exact meaning of these markings remains a subject of debate, many scholars believe they represent an early attempt at counting and perhaps even basic mathematical operations.
Early humans also relied on their own bodies for counting. Fingers and toes served as natural counters, allowing for simple calculations and the exchange of numerical information. The rising and setting of the sun, the cycles of the moon, and the changing seasons provided a framework for understanding time.
These early attempts at counting may seem rudimentary by today's standards, but they represent a profound cognitive leap. They mark the moment when humans began to move beyond the immediate perception of their senses and into the realm of abstract thought, a realm where numbers would come to play a defining role. The invention of writing, a watershed moment in human history, forever changed our relationship with numbers. In ancient Mesopotamia, nestled between the Tigris and Euphrates rivers, the Sumerians developed a sophisticated system of writing known as cuneiform.
Cuneiform, meaning wedge-shaped, involved pressing a stylus into wet clay to create wedge-shaped marks that represented syllables and words. Crucially, the Sumerians also developed a system for representing numbers using cuneiform. Their system, based on the number 60, is still evident today in our measurement of time: 60 seconds in a minute, 60 minutes in an hour, and angles, 360 degrees in a circle.
The adoption of a base 60 system by the Sumerians may seem unusual today, but it likely stemmed from practical considerations. The number 60 is divisible by many smaller numbers, making it well suited for calculations involving fractions, which were essential for trade and commerce. The Sumerians' invention of a written numerical system was a revolutionary development. It allowed for the recording of complex transactions, the tracking of large quantities of goods, and the preservation of mathematical knowledge across generations. This laid the foundation for the development of more advanced mathematical concepts and paved the way for the scientific and technological advancements that would follow. Throughout history, numbers have held profound significance beyond their practical applications. In many cultures, numbers bridged the earthly and the divine.
In Mesopotamia, each deity had a specific number. The god Anu was linked to 60, the most powerful number. Numbers reflected a belief in a mathematically governed universe.
In India, zero symbolized the void and the infinite. Zero's development profoundly impacted global mathematics. Numbers provided a framework for understanding the cosmos. This connection influenced mathematics and science for centuries. The invention of numbers and the development of mathematical systems had a profound impact on human civilization.
Numbers became the backbone of trade and commerce, enabling the exchange of goods and services.
With the ability to quantify goods and calculate profits, merchants could expand their operations, leading to the growth of cities and empires.
Monumental architecture, like the pyramids of Egypt and the Great Wall of China, required sophisticated mathematical knowledge.
Numbers revolutionized warfare.
Military strategists use mathematics to plan troop movements and supply lines.
Accurate maps, made possible by advances in geometry, gave armies a strategic advantage.
Numbers also advanced science and technology.
Ancient astronomers used calculations to chart celestial bodies, developing calendars and predicting eclipses.
Geometry laid the foundation for understanding shapes, while algebra solved equations and modeled phenomena.
The power of numbers to shape civilization is undeniable.
From early trade routes to scientific discoveries, numbers have driven human progress.
Section 6. Beyond counting, the language of the universe. As our understanding of numbers grew, so too did our realization that their significance extended far beyond simple counting. Numbers, we began to understand, were not merely human inventions, but rather the fundamental language of the universe, a language that governed the laws of nature and held the secrets to the cosmos. Sir Isaac Newton, the father of classical physics, famously said, "Truth is ever to be found in simplicity and not in the multiplicity and confusion of things." Newton's laws of motion and universal gravitation, expressed in elegant mathematical equations, revealed the underlying order and predictability of the universe. From the orbits of planets to the behavior of subatomic particles, the same mathematical principles applied, demonstrating the universality of this numerical language. The discovery of new elements, the prediction of chemical reactions, and the development of new technologies all stemmed from our growing understanding of the mathematical principles that govern the natural world. Numbers were no longer simply tools for counting or measuring. They were the keys to unlocking the secrets of the universe. Section 7. Numbers in the Digital Age, a World Transformed. The invention of the computer in the 20th century ushered in a new era in our relationship with numbers. Computers, with their ability to process vast amounts of numerical data at lightning speed, have revolutionized every aspect of modern life.
From the smartphones in our pockets to the complex algorithms that power the internet, numbers are the lifeblood of the digital age. The binary language of zeros and ones, representing the on and off states of electronic circuits, forms the foundation of all digital technology.
This digital revolution has led to an explosion of data, creating unprecedented opportunities for scientific discovery, technological innovation, and economic growth. Data analysis, powered by sophisticated algorithms and machine learning, is transforming industries from healthcare to finance to transportation.
We live in a world increasingly driven by numbers. A world where data is the new currency, and algorithms shape our decisions, our experiences, and our understanding of the world around us.
Section 8. The Uncountable Future. Mysteries yet to be solved. Despite our remarkable progress in understanding the language of numbers, many mysteries remain. The vastness of the universe, with its countless stars and galaxies, continues to inspire awe and wonder. The enigmatic nature of black holes, the search for extraterrestrial life, and the quest to understand the fundamental nature of reality continue to challenge our current understanding of physics and the limits of mathematics. New branches of mathematics, such as chaos theory and fractal geometry, are revealing hidden patterns and complexities in seemingly random systems. Quantum mechanics, with its strange and counterintuitive laws, suggests that the universe may be even more bizarre and wondrous than we ever imagined. The journey of numerical discovery, begun by our earliest ancestors, is far from over. As we continue to explore the universe and delve deeper into the mysteries of existence, numbers will undoubtedly continue to play a central role, guiding our quest for knowledge and shaping our understanding of the cosmos. Section 9. Conclusion: Our enduring fascination with numbers. From the earliest tally marks etched on bones to the complex algorithms that power our digital world, numbers have played a defining role in the human story. They have enabled us to trade, to build, to explore, and to understand the universe around us. More than just tools for calculation, numbers have inspired awe, wonder, and a deep-seated desire to find meaning and order in the cosmos. They have connected us to the divine-fueled scientific discoveries and shaped the course of civilization. As we stand at the cusp of a new era of technological advancement, our fascination with numbers shows no signs of waning. The journey of numerical discovery, begun millennia ago, continues to captivate our imaginations and drive our quest for knowledge. The language of numbers, it seems, is not merely a human invention, but a fundamental aspect of the universe itself, a language that we are only beginning to decipher. The more we learn, the more we realize how much more there is to discover. And so, the journey continues, driven by our enduring fascination with the power and mystery of numbers.